Hi guys, welcome to Backbenchers tuition, and today we are going to talk about the series parallel complex circuit. On my previous video I have talked about the single series circuits and the parallel circuits, but today we are going to talk about the series parallel complex circuit. A series parallel complex circuit is that kind of network where we will find the both series resistors and the parallel resistors. As you can see over here, R2 and R3 is parallel, and those two resistors is series with R1 resistors, and those two resistors is parallel with R4 resistors. So as you can see, we got all kind of resistors here. There's a lot of method to solve a complex circuit, but today I'm gonna use the redraw method, which is kinda easy, I guess. So redraw that is pretty much easy, but we just need to remind two important things. So these two important things is one, always same current on a series network. And number two is always same voltage on a parallel network. Only we just need to remember those two things, only those two things. Always same current on a series network and always same voltage on a parallel network. Okay, and then we are gonna use the Ohm's law, which is V equals to IR, and that's how we are gonna solve this problem. Okay, so we're gonna solve this problem like we are gonna find the branch current through this resistor, this and this. We are gonna find the voltage through this resistors. Okay, so as you can see, the method is called redraw. So we are gonna redraw the circuits a couple of times. Okay, so let's get started. As you can see over here, I just finish our, we'll call this first redraw. Okay, so as you can see, R2 and R3 resistors are in parallel, so we are gonna make them in parallel. This is the voltage source, and this is the R1 resistor, and this is the parallel resistor R2 and R3, and this is the R4. Okay, so R2 and R3 as a parallel network, so we are gonna solve it like this. Okay, we just put the values. 12 volt, this is 6.8 kilo ohms, this is 8.2 kilo ohms, and this we are gonna call it R1 prime. Okay, so R1 prime will be like 1 over R1 plus 1 over, sorry, excuse me, R2 and 1 over R3. So that will be like 1 over R1 plus R2, which is 18 plus 1 over 2. So calculate the values. 1 over 18 plus 1 over 2, like 9, and then reverse the answer, which will be 1.8 kilo ohms. Okay, so and we are gonna call this R1 prime, which is 1.8 kilo ohms. Okay, so and that's how our first redraw is done. Now we can move to our second redraw. the second redraw. Excuse me. Second redraw. So the second redraw, as you can see, this register and that register is on series network. Okay, so we can just put this in a total resistance, and that would be the R4, which is 8.2 kilo ohms, and this is the voltage, which is 12 volt, and as you can see that two resistors, which is we can call it R1 double prime. Okay, so R1 double prime will be that, as you can see, this is the R1 plus, and that resistor R1 prime, so that will be 6.8 plus 1.8, which is 1.8 plus 6.8, which is 8.6 kilo ohms, and this is the resistor 8.6 kilo ohms. And that's how our secondary redraw is done. And now we are gonna make the third redraw, which is gonna be our final redraw. So we are gonna name it the final redraw. Okay, so our final redraw will be like this resistor and that resistor is on. As you can see, those two resistors are on a parallel network. So to find the total resistance of this two network will be like the parallel resistor. Okay, so we're gonna draw the circuit, and we're gonna, okay, so that will be like, let's just solve us. So that would be, let's just call it the RT, which is the total resistance. Okay, so RT will be 1 over 8.6 plus 1 over 8.2. So excuse me, this is 1 over RT, so 1 over 8.6 plus 1 over 8.2. okay, so as you can see, the result says 420 1763. So the RT will be 1763 over 420. So that will be the inverse, okay, which is 4.197 kilo ohms. This is the resistor, total resistance of this network, which is 4.19. Okay, now we know the source voltage 12 volt. We know the total resistance of this network, which is 4.19. As you can see, we have the voltage E equals to 12, resistor R equals to 4.19. Now we can easily find the current with this formula, with this Ohm's law. V equals to IR, then I will be like V by R. So that will be 12 over 4.19, which will be 12 over 4.19, which is 2.86 milliamps. So we got the current through this network, which is 2.86 milliamps. Okay, so now we have the resistor, the current, and the voltage. Okay, so now we need to find the branch currents of this resistor, that resistor, and those two resistors, and the branch voltages, of course. So now we are gonna reverse this. Okay, so we're going to our second redraw. I hope you guys remember I have told you always the same voltage on a parallel network. As you can see, our second redraw, which is the parallel network. So the voltage of these resistors will be same. So the voltage which is 12, so the resistor voltage will be 12 volt and this resistor voltage will be 12 volt. We got the voltage, we got the resistor. Now we can easily find the current. The branch current will be I equals to V by R. So we are gonna solve it. V by R, which is 12, 8.6 and 12 over 8.2. So which is 12 over 8.6, which is 1.39, and that is 12 over 8.2, which is 1.46. Okay, we don't know the answer is right or wrong, so we are gonna prove this answer. 1.39 milliamps and 1.46 milliamps. As you can see guys, on our final redraw, this is on our final redraw, this current. Okay, so that means that current divided into that current and that current. So these two, the sum of these two currents will be 2.86. Let's see, we got 1.39 and 1.46, which is 2.85. As you can see guys, which is 2.85. we have some decimal issue, so that's we didn't find the accurate answer, but it is 2.85. Okay, that means our answer is correct. Okay, so now we are gonna reverse this again. We are gonna move to our first redraw. Okay, as you can see guys, on that resistor and that resistor is the same, so there's nothing changed. Okay, so that will be 12 volt and the current will be 1.46 milliamps. But over here the resistor divided. Okay, and you guys already know always same current on a series network. So this is a series network. As you can see, those two resistors on in series, so always the same current. So we are gonna put this current over here, which is 1.39 milliamps and 1.39 milliamps. Now we got the current, we got the resistor. Now we can easily find the voltage, branch voltage. So the voltage V will be V equals to IR. So that will be I, which is 6.8 into 1.39 and and 1.8 into 1.39. Okay, so 6.8 into 1.39, which is 9.452 volt, and 1.8 into 1.39, which is 2.502 volt. So we can just write it down over here, 9.45 and 2.50. Okay, so as you can see guys, this voltage divided over here, so we are gonna check the value, which is 9.45. As you can see guys, it is 11.952. that means it's kinda like 12. Okay, so our answer is correct. Now to our first network, we're gonna move to our first network. on this network, let's just see which value is changed. Okay, on this network our R1 and R4 registers, we got no change, so we're gonna measure this current. Okay, 1.39 milliamps. Over here we got 9.45 volt. Over here we got 1.46 milliamps and 12 volt. Okay, now as you can see guys, it's a parallel network and we know the rules, always the same voltage on a parallel network, and we got the voltage from here which is 2.50, so we're gonna write it down, 2.50 volt, and for this 2.50 volt. So as we got the voltage 2.50, now we're gonna easily measure the current, which is I equals to V over R. V, which is 2.50 over 18, which is 0.138 milliamps, and 2.50 over 2, which is 1.25 milliamps. Now as you can see guys, we got here 1.39 milliamps, so let's just see we got this value or not. 0.138. As you can see guys, 1.388, that means the value is correct. Now we got the current and voltage for R1 register, we got the current and voltage from R2 register, for R3 and R4. As you can see, we got all the values. Now this is pretty much easy, we just need to redraw the circuits and then we are gonna find the total resistance by that, and then we are gonna solve the current and the voltage with the two rules: always same current on a series network and always same voltage on a parallel network, and then we are gonna apply the Ohm's law. I hope that was pretty easy. Practice it, and I'm gonna solve another problem on my next video, so that will be helpful for you guys. And if you don't get anything, so then comment me below, and please guys, don't forget to subscribe, like, share, and if you want any kind of tutorial, you can comment me below. I will try to get back on that. Anyways, I'm out. Have a nice day.